In this video, I'd like to introduce the concept of inheritance. Now, to understand inheritance, let's refer back to our computer class that we've been working on in previous videos and consider the fact that there are actually multiple different kinds of computers in the world. For example, I could have a laptop computer. In fact, that's what I'm working on right now. But I also have a tablet computer. And while they're both computers, they actually do different things. They have different capabilities from one another, but they also have some things that are common to both. So if we look at our computer class, for example, both a laptop and a tablet has memory and a processor. Computers can't operate without those things. They also have a size and a brand, as all computers do. Um, so they share these features in common, but they also share some features that aren't in common across the two different types of computers. For example, laptops can typically open and close. So I can open or close a laptop, whereas tablets are usually just a single tablet that can't open or close. Tablets often have touch screens, and while laptops are more often getting touch screens these days, um, you know, I don't typically think of a laptop as necessarily having a touchscreen. I think of a touchscreen as being a defining characteristic of a tablet computer. So what if we wanted to create laptops and tablets in code? It might be tempting to just go ahead and add those features in. For example, if I wanted to make an open or close method for my computer, I could add that in. But the problem is, if the computer that I was creating represented a tablet, that behavior would not be something that a tablet could actually do. So I would have this behavior that's not applicable to the object that I've created. Similarly, for a tablet, if I wanted to create a way to use the touch screen, then if I had a laptop or some other computer that didn't have a touch screen, it would be able to use that behavior in the code, even though the actual object doesn't necessarily have the ability to use that behavior. So if we want to reuse some of this code, reuse the stuff that's in common between these objects, but also be able to make different kinds of objects that are a bit more specific with their own unique sets of behaviors, we can use this idea of inheritance. Now, if we go back to relationships, we'd say inheritance has an is-a relationship. So we'd say a laptop is a computer, a tablet is a computer. That means that those are good targets for inheritance. Now let me show you how this works. What I'm going to do is I'm going to create a new class. I'm going to create a class for a laptop first, let's say. So let me go in here and create my new class. I'm going to create a laptop class. And since we just said that a laptop is a computer and it shares many of the features that are in common with all computers, I want to be able to reuse this code. All of these things apply to laptops, so I want to be able to reuse this code without having to rewrite all of it in my laptop class. In order to do this, I can go up here to my class definition and I can say a laptop extends computer. This is inheritance in action. This will allow the laptop class, to inherit all of the methods and properties, the fields, from this particular class. Okay? So we see Eclipse is mad right now. Let's take a look and see. All right, yeah, so we're going to take a look at that in just a second. Excuse me. So like most classes, we need to think about the fields and behaviors associated with a laptop class. So the difference between what we do with the laptop and the computer class is I don't have to duplicate anything that's already in the computer class. The inheritance, by extending the computer class, means that I will already have these properties in my laptop class. So I only need to think of things that are different. So for a laptop, I might want to make a simple state field that indicates whether the laptop is currently open or closed. So I'll call this a Boolean. Actually, let me make it a private Boolean. Is closed. Okay? For the behaviors of the laptop, we do definitely need a constructor. That's sort of a special case that I want to talk to you about. But I also want to create a behavior that allows us to open or close the laptop. Okay? So let's talk about the constructor first, since that is sort of a special case. I'm going to go ahead and create my constructor here for my laptop. And just like we did for the computer, I'm actually going to allow it to take in the same parameters because I need to be able to set those parameters, right? Now you may be thinking that, okay, since I took these parameters in, the next thing that I'm going to do is say this dot memory equals memory, this dot size equals size, et cetera, et cetera. But that would actually be a duplication of code that I've already written. So if I want to, I can call the constructor from my base class, right, from the computer class using a special technique called super. Super is a special word, you see Eclipse turned it purple for me, that calls the constructor of any class that I'm currently inheriting from. Memory, size, processor, brand. And this will create a new laptop for me that actually is using the same constructor from the computer. That's actually okay because the laptop needs to have all of these values as well. Now the only thing that I need to worry about in my constructor are any additional values that I've added. So you see here I've got this Boolean that I've created, and I'll start is closed off as true. Okay? So oftentimes with inheritance, this is what your constructors will look like. There has to be a call to the superclass, or the base class might be what we call it, that calls the constructor from that class. And then any additional properties, any additional fields that I have, I need to set those in the constructor of my derived class, the class that's inheriting from the superclass. So now that I have that taken care of, I can create my behaviors. I'll create a couple of very simple methods, public void close, which will close the laptops. That just sets this dot is closed to true, and then I'll create another one, public void open, that sets is closed to be false, opens the laptop. And now I've defined the behaviors that are specific to my laptop that don't necessarily apply to all of the computers in the world. Let's try this again. This time, let's create our tablet class. Now remember, our tablet class is going to have the ability to use a touchscreen. So let's take a look at how we can create a tablet class and utilize inheritance again. So let me create a new class, tablet. So here's my new tablet class, and just like I did last time, since the tablet has many of the same features that are already existing in my computer class, memory, size, processor, and brand, I'll go ahead and extend the computer class. Now it should be noted that I can only inherit from one class. There's only one class that I can ever inherit from. If I try to extend from multiple classes, Java will not let me do so. In terms of properties for the tablet, I'm not sure that I need any. I don't think there are any additional hasas that I necessarily care about. But there are some additional behaviors, specifically a touch behavior. Before we get there, though, I do want to take care of the constructor again. So I'll say public tablet and take in all of those parameters. I'm just going to go over and copy paste this, actually, to save myself some time. Okay, so I've got an extra parenthesis there. I don't have this is closed parameter. That was from my laptop, so I'll go ahead and take that out. So the only thing that I'm really doing is calling the super, calling the constructor of my base class. And now I can add in any different behaviors that I want. So in this case, I'll create a touch method. And all I want this touch method to do is, well, let's take a look here. Actually, where I'm touching is important. So I'll take in a couple of coordinates here, int x and int y. That's going to represent the x and y coordinate of the tablet that I'm touching. And I want to make sure that the values, the x and y values, are actually on the tablet. That is, I haven't gone off the edge. So they can't be negative, but they also can't be bigger than the size of my tablet. So what I want to do is actually check x and y and make sure that they're both within an acceptable range before I do any kind of behavior with this method. So I'm going to stick some if statements in here. If x is greater than 0 and x is less than this dot size. Now remember, we have the ability to access the size property since we are within the same class, right? So I'll do the same thing for the y value. Y is greater than 0 and y is less than this dot size. Now you see that while I said I have access to those fields, Eclipse is a little bit mad at me right now. If I hover over this, it'll tell me what the problem is. It's telling me that computer.size is not visible. So let's talk about what this means for a second. I have this field called size. It's in my computer class. Tablet extends the computer class. That means it inherits everything that the computer class has, all of the methods and all of the properties. The problem is that I have these fields marked as private. And when things are marked as private, it means very, very, very private. That means that even the class that's inheriting from the computer class cannot see this particular field. Now, in this particular case, I want my class, my derived class, to see those fields, to use those fields. I'm trying to use these fields. So there's a special access modifier that's used with inheritance called protected. So once whoops, I changed the wrong one. Let me change size. So once I change size to protected, if I go back to my tablet class, you see that Eclipse is now happy. So what does protected do for us? Protected is very much like private. If something is marked as protected, it's still invisible to the outside world. The outside world cannot access that variable. But any classes that inherit from this class can see that variable. So with that in mind, you should keep things marked as private. For most things, that is what they should be. If you're ever using inheritance, then if you decide that you need access to a field in that derived class, then you may want to go in and mark your fields protected at that point in time. Now that gives us the ability to see that size variable. And just for simplicity's sake, I'm going to make a very simple print statement that says, touched the screen, just to indicate that this behavior is working. Okay? So we are now finished. Whoops, it's unhappy about something. It's marked as protected. It says it's not visible. Why is it not visible? Size is marked as protected. I think that's actually okay. I'm going to try it out and see. So let's create some main methods to actually try some of this stuff out. So for example, I'm going to come down here and make a main method. And in this main method, I'm going to create a new tablet. Tablet t equals new tablet. And I have to specify all of the values for the constructor. So the memory, I'll give it 8. I'll give it a size of 15. I'll give it a processor of, it doesn't really matter, and a brand of Lenovo. And now if I want to try this out, I can say t.touch, and I have to give it an x and y value that meets my my standards there. So I'll say 5 and 10, which are both less than the size. They both should be able to be part of, they should both fall within this range that I've specified here. So let's try this out. If I go ahead and run this now. Yes, I do want to save my things. It says that I have touched the screen. So it actually was successful. I managed to access the size values. Since they are protected, that means that I can actually see them within this derived class. Okay. If I wanted to, I could also test the functionality of my laptop class as well. So you see that I've got open and close that I could, play around with and set these values, print them out if I wanted to. But instead, I'd like to show you one final feature of inheritance, and this is actually very, very important. So I'm going to create another main method down here. And in this main method, I'm going to create both a laptop, new laptop. I'll give it some values here for the memory. What's next? The size, the processor, and the brand. And I'm also going to create a tablet. In fact, I might go one step farther. And just for the heck of it, I'm going to also create a computer. Oops, I made a mistake here. It says new laptop. It should say new tablet. Sorry about that. I'll go ahead and create a new computer down here as well. Okay, so I'll just go ahead and leave those values as they are. Let me change these actually. I changed my mind. I want to change these a little bit. And so now I have three different computer objects. One is a laptop, one is a tablet, and one is just a regular old computer. But what you'll notice is that anything that's in the computer class, since that is my base class, that is what all of the other classes inherit from, can be used with any of these objects. So I can, for example, print out all three of them. L, and I'll do the same thing for T. Or maybe instead of printing them, I will go ahead and say get brand instead. L.getBrand, T.getBrand, and C.getBrand. And if I run this, you should see that it actually will display the brand of all three of these computers. Apple, Lenovo, and HP show up on my console. So what happened there? The laptop class does not have a method called getBrand. It does not exist anywhere inside of this method. The same thing is true for tablet. It does not have a method called getBrand. So what happened? When I called getBrand on this particular object, it went to the class and said, hey, where's the getBrand method? It couldn't find it. But then it saw that I'm inheriting from the computer class. So it went back to that base class, that computer class, and says, hey, do you have a getBrand method? And it found it. It found it right here. So it managed to get the brand and retrieve it successfully. So you can see that I'm utilizing that common functionality that exists across all of these different things. Now what you'll notice, what else I can do with this feature is, let's say I have an array list of computers. Oh, I need to give it a name. New array list. So I've created a brand new empty array list with these computers. I need to import the array list class to make this happy. There we go. And now, if I want to, I can actually add all three of these things to that array list, which may not seem intuitive at first, but let me show you that it does in fact work. Computers.add C, computers.add L, computers.add T. So you notice that I've added all three of these things to the array list. The reason that that works is because laptops and tablets inherit from the computer class. So what that means is that I can actually treat them as computers when it's convenient for me to do so. This allows me to group all classes that inherit from the same base class in one object, like an array list. That's a very convenient thing to be able to do. This is a feature in Java called polymorphism. And what polymorphism means is that if I have classes that are inheriting from other classes, I can treat that class as either the actual class that it is, in this case a laptop, or I can treat that object as a computer if it's convenient for me to be able to do so. That is polymorphism in action. Okay, that's going to wrap it up for my video on inheritance. I will see you next time.